All right, pay attention, please. Today we're going to be solving equations again, but we're going to be solving equations with infinite solutions, infinite and no solutions. So you'll have three types of equations today. One, just regular equations like you've been solving. There's gonna be a value for the variable. Then this is the symbol for infinite. So you'll have some equations that have infinite solutions. And then you'll have other equations that have no solutions. All right, so we're going to say that an equation that is true for every possible value of the variable is an identity. And an equation has no solution if there is no value of the variable that makes the equation true. All right, so let's say you have a problem, an equation that you're trying to solve. And if you get to the point where, let's say you have x plus 1 is equal to x plus 1. Do you see how both sides of the equation are exactly the same? That's an example of infinite solutions. All right? An identity. Let's see, go back up here where this says identity, maybe put comma, and you can write infinite solutions. All right, so if x plus 1 is equal to x plus 1, then infinite solutions. Identity. If you get to the point in a problem where x plus 1 is equal to x plus 3, all right, look at this problem here. If you were to subtract x from each side, look what happens. You get 1 is equal to 3, right? Well, is 1 ever equal to 3? 1 is never equal to 3. If you get to that stage in a problem or anything that looks like that, then no solution. All right, and that's what you would write. You can abbreviate it. You can just write NS, no solution. But if you get to a point in the problem where the left side, you know the left side's not going to equal the right side. If you get to 5x is equal to 6x, is that ever going to be true? 5 times a number is never going to equal 6 times the same number, is it? Okay? That's no solution. All right, so let's look at a couple of examples. We'll start off with 3 times 4b minus 2 equal to negative 6 plus 12b. So we're going to do the distributive property first on the left side. We've got our 3 times 4b is 12b minus 3 times 2, which is 6, equals negative 6 plus 12b. Some of you will recognize this right now. Careful. Because watch, if you subtract 12b from each side, don't these cancel? And the negative 6 falls down. And on the right-hand side, 12b minus 12b cancels, and the negative 6 falls down. So doesn't negative 6 always equal negative 6? Okay, so that's infinite solutions. That's identity. You'll see it as identity, or you'll see it as infinite solutions. Make sense? A little bit? Let's look at 4 times 2y plus 1 equal to 2 times y minus 13. So in this case, we've got distributive property on both sides. So I'm going to distribute the 4 first. 4 times 2y is 8y plus 4 times 1 is 4. And then I'm going to distribute the 2 on the right-hand side. So 2 times y is 2y minus 2 times 13 is 26. So just keep solving it regular until you can't move any further. 8y minus 2y is 6y plus 4 equals negative 26. Subtract 4 from each side. So 6y is equal to negative 26 minus 4, negative 30. Divide both sides by 6. And our y is equal to negative 5. So negative 5 is your solution. In that case, the problem was not an identity, and it had a solution. See the difference in the two? The difference between identity and just a regular old problem that's got a solution. And then we'll do in an example here of no solution. So let's go 2x plus 7 equal to negative 1 times 3 minus 2x. All right, so the 2x plus 7 on the left-hand side, that stays the same. And we get negative 1 times 3 is negative 3. And then negative 1 times negative 2x, and that would be positive 2x. So if we subtract 2x from each side, the 2x's here cancel and the 7 falls down. And the 2x's here cancel and the negative 3 falls down. And is 7 ever equal to negative 3? No. So what do we call that? No solution. Questions? Pretty straightforward? All right, if you get stuck or confused during the problem, come see me. I'll talk you through it. Your practice for today is going to be on page, and I'm going to put it up on the wall here in a minute, and I'll also post it to focus. So it's page 105. We're going to do 1 through 4, and then 10 through 12. Oh.